trig functions and right triangle trig ratios with Kent and Chow. So before starting the lesson, there's a few pieces of knowledge everyone should know. Trig functions are used to help find missing sides and angles of triangles. There are three major trig functions, which is sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. In addition to this, there's the unit circle definition of trig functions, which is cosine is equals to x and sine is equals to y. Using the unit circle definition, you can also use the formula tangent is equals to sine over cosine. Now, if you're having trouble memorizing the three major trig functions, you can use the widely used acronym, which is SOHCAHTOA. So what is opposite, adjacent, and hypotenuse? Looking at a right triangle, you want to identify the two markers, which is angle theta, which is the reference angle, and the 90-degree marker. So directly across from the 90-degree marker is the longest side, and this is referred to as the hypotenuse. Now going back to angle theta, directly across from it, or opposite from angle theta, is the opposite side. The last side is obviously the adjacent side, and the adjacent side is the angle that's touching, the side that's touching the angle. However, it cannot be the hypotenuse. So this is the hypotenuse already, so this must be the side that we're talking about. Now this is problem 1. They're asking you to identify the trig ratios that correspond with the trig functions. Now you can pause the video here and try to figure it out for yourself, or you can follow along with me. So the first one is sine of theta. We identify theta, and using the acronym from earlier, SOHCAHTOA, we see that sine is which is opposite over hypotenuse. So it should be b over c. Going on to the next trig function, which is cosine of theta. We have theta, and then cosine is equals to ka, which is adjacent over hypotenuse. So adjacent over hypotenuse, which should be a over c. Now tangent is also equals to opposite over adjacent. So this would be b over a. Now using the formula from earlier, we can also find tangent by plugging in the numbers from the formula, which say sine, which is b over c, is divided by cosine, which is a over c. Now when you're dividing two fractions, you find the reciprocal and then you multiply. In this case, you can cross cancel the c's and get b over a, which is the value for tangent over here. This is problem 2 using a unit circle. So here cosine is equals to x and sine is equals to y, and we're asked to identify the trig functions that correspond with the trig ratios that are already given. Again, you can pause this video and work it out for yourself, or you can follow along with me. So the first one is x over 1. Angle theta is right here, and x, which would be the adjacent side, is over 1, which is a hypotenuse. So earlier we said that SOHCAHTOA, ka, which is adjacent over hypotenuse, which is x over 1. So this would be equals to cosine. Now, in addition to this, cosine is also the x value, and here x over 1 is also equals to x, so this can also be cosine if you figured it out using it that way. Next we have y over 1, and using the unit circle definition, y is also the sine value, so right off the bat we can know this is sine, or we could use the triangle and figure it out by using theta, and right across from theta, which is the opposite side, is y, and then over 1, which is the hypotenuse, so opposite over hypotenuse is sine. Next we have x over y. That's weird. we have x over y. We haven't learned that yet, but you can see that this is the adjacent over opposite. So we know that tangent is opposite over adjacent, and that seems to be the inverse of tangent. So for now, we can put 1 over tangent, and we can learn more about inverse trig functions in a later video. So the last one is y over x. You see angle theta, and across from angle theta is y, and then x, so it's opposite over the adjacent side, which is x. Opposite over adjacent is tangent, and there you have it.